In this video, you'll get more information about how to use the project type New Project Parts for digital assembly. It covers alignments for individual parts, alignments between multiple parts, and inspections that allow you to evaluate the digital assembly. First, open or create a project with multiple parts. If you need more information on how to create a project with multiple parts, have a look at the video Digital Assembly, Create and Manage Projects with Multiple Parts. I'll open an existing project. Before you can inspect the digital assembly of multiple parts, you need to position the parts in your project accordingly. So let's start with alignments. There is one very important distinction when it comes to alignments in projects with multiple parts. You have to distinguish between two types: the traditional alignment between nominal data and the mesh or actual data, and the interpart alignment. With the interpart alignment, you create an alignment using the mesh or actual data of two or more parts. Based on these two alignment types, you have a lot of flexibility. You can create alignments within one part, that means actual to CAD or nominal, and you can create alignments between different parts, either by aligning the actual of one part to the nominal of another part, or by using interpart alignments. In the next few minutes, I'll show an example for both options. Let's start by aligning the actual of one part to its nominal. For my example, I'll use the pre-alignment. To create an alignment, select a part in the Explorer. By selecting a part in the Explorer or the 3D view, the software recognizes this part as the active part and uses it as default for the creation of elements, including alignments, geometric elements, etc. Now, click on the plus in the main toolbar and select the alignment you want to create. You can also click on the plus and then select the part in the dialog window. In the pre-alignment dialog, you can select a target element. This allows you to align the actual of your part to the CAD or actual of another part. If you don't define a target element, like me, the software creates the pre-alignment between the actual and nominal of the part. You can also create one or multiple main alignments for each part in your project. I'll create an RPS alignment to give you an example. Click on the plus and select RPS. Now select the elements that you want to use for the RPS in the Explorer or the 3D view. I'll use 4 circles. Click Add Selected Elements. Define the direction and click OK to create the alignment. For more information about alignments, have a look at the direct help. The second part in my project, the M, is already pre-aligned. Now, before I show you how to create an interpart alignment, I'll use the feature Surface Distance. It allows you to display the deviation between the meshes of two parts as color plot. You could also use it to display the deviation between two CADs or the CAD of one part and the mesh of another part. This allows me to evaluate the current alignment between the two meshes. Open Construct, Distance, and click Surface Distance. Select an area on the part you want to evaluate. Under Target Element, fill in the other part. You can use the drop-down list or press Ctrl and click on the part. If the surface directions of the two parts point in opposite directions, like in my case, you need to check the inverted surface direction. To do that, click the button Invert Surface Direction. To create the surface distance and close the dialog, click Create and Close. The deviation representation sets the baseline for the interpart alignment. The goal is to minimize the deviation of the positioned M on the GOM plate in the digital assembly. To do that, you can use different interpart alignments. In this tutorial, I will use the alignment by coordinate systems. But you could also use a local best fit, an RPS, or an alignment by geometric elements, for example. My project already contains the 2 actual coordinate systems I want to use. To create the alignment, click the plus in the main toolbar. Now select the alignment you want to use. I'll select by coordinate systems. Under Target Coordinate System, select one of the 2 actual coordinate systems you want to use. Be aware that the software will move the part to which the actual coordinate system belongs to the target. So, I'll use the coordinate system on the GOM plate as target. Under Actual Coordinate System, select the one on the part that you want to align. The software assigns the interpart alignment to one of the parts and displays a note in the dialog window. You can find the alignment in the Explorer. To see a quick overview of all the main alignments and which parts they belong to, you can use the tab Table. Now that I've used the interpart alignment for the digital assembly, let's look at the surface distance again. As you can see, the 2 actual parts match well. This was just a very brief first look at projects with multiple parts. If you have any questions or want to give feedback, please use the forum.